Hey guys, it's Mr. Brian here. In this video, I'm partnering with EduKaji to guide you on the SPM 2021 physics paper. We'll be discussing paper 1 today on your objective questions. Without further ado, let's get started. Okay, so paper 1, 1 hour 15 minutes, 40 questions. That's that. Question 1. Which quantity is a base quantity? Well, you only have 7 base quantity and you must know all of them. They are the most basic ones. It is current. Okay, so what are the 7 things like mass, length, temperature, current, luminous intensity, as well as amount of substance. Amount of substance is the symbol is N. Okay, I'm missing one. What else? Oh yes, time. Okay, so time, mass, length, temperature, all the most basic ones. Current, luminous intensity. Luminous intensity means like the brightness. Amount of substance, the symbol is N. Yeah. Usually N represents number. This one it's in the symbol M. N. Okay, number 2. The driver and passengers of a car are advised to wear a seatbelt. Seatbelt prevents them from being thrown forward and hurt themselves. The purpose of wearing a seatbelt is to reduce the negative effect of B, inertia. Okay, so inertia is talking about how when the car is moving forward, your body is also continuing the forward motion. Your body is moving forward, the car is moving forward together. So when the car suddenly stops, maybe because you step on the brakes very hard, the body still wants to continue its motion forward. Guys, that is inertia. Inertia talks about how difficult is it for you to stop something from moving forward, or how difficult is it for you to move something that is resting, for example. Yeah. Okay. So that body moving forward, that thing is called inertia. Your body has inertia. It wants to keep on continuing its motion forward. Your body gets thrown forward. Okay. That's the best answer. C. The diagram shows Abu drop a box off a cliff at a height of 15 meters. One is on the Earth's surface, one is on the Moon's surface. If Abu does the same activity on the Moon using the same box, which quantity will increase? Okay. Time taken for the box to reach the surface. Yes, I think that is the answer. Because why? If I drop it on the Moon, because, okay, by the way, you all know the Earth's surface has an acceleration of 9.81. Okay, you don't have to memorize the gravitational acceleration on the Moon, but just to give you a little bit of context, usually the value is roughly around 1.63 or 625, 63 meter per second squared, which means it is much slower the acceleration is much lower. Of course, it will take longer time to reach the ground. That's why I think answers A. The gravitational field strength will not increase, it will decrease. Gravitational field strength and also gravitational acceleration is the same thing. The value is the same. It's also 1.63 meter per second squared. Okay, same thing. So no, this one will decrease, not increase. Weight of the object will decrease also. Why? Because when I compare Earth and Moon, when the G becomes smaller, the W also becomes smaller. So the G is smaller. Only the T will increase. We are looking for the quantity that increase. Okay, lastly, mass of object. Mass of object unchanged. Guys, be careful. You must make sure you know the difference between weight and mass. Mass will never change wherever you go, whatever planet you are at. Okay, but weight will change depending on your gravitational field strength or gravitational acceleration. Yeah. Okay. Number 4. Mei cycles from a house to school. On her way back from school, she stops at a grocery store behind her house. Diagram 2 shows the displacement time graph for a journey. Which velocity time graph describes the movement of Mei? Okay, so this is a classic question on changing a displacement graph to a velocity graph. Displacement to a velocity graph. Now, I always tell my students, when you're looking from a displacement to a velocity to an acceleration graph, when you want to change one to the other, you always go and find the gradient of the graph. The gradient of this displacement graph is the velocity. Velocity is the gradient is the velocity. So if you're trying to go from S graph, this is your S graph, trying to go to a V graph, what do? Find the gradient. Find the gradient here, 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 done. If let's say you're trying to have a V graph from a V graph trying to find the acceleration, then you also find the gradient. Now, what do I do if I want to move backwards? Acceleration graph want to find velocity, then how? Or velocity graph want to find displacement, then how? Then you find the area under the graph. Okay, this one all you must know. You also did this in maths. If you learn from 5 at maths last chapter already, also you will deal with this a little bit. Okay, right. So the question is, what is the gradient here? It's definitely a positive value that keeps going up. This is a fixed positive gradient. Okay, you want to go and calculate also can, but I don't think you need to. Here, the gradient is 0. Yeah, if a graph is going up, it's positive gradient. If a graph is going down, the gradient is a negative value. Negative gradient means negative velocity. 0 gradient means velocity also 0. Positive gradient means velocity also positive. But it is a fixed value, guys, because we learned for any straight line, the gradient never change one. It's always the same in maths. Y equals mx plus c, right? Straight line. Okay, so we're going to look for a positive, 0, and then negative line. Looks like B is the answer, boy. Don't worry about, some people would think like, teacher, will QRS here be different? Okay, so you see from OP is just one fixed value. OP is one fixed value. PQ is 0 totally. From Q to R, guys, as long as it's a continuous straight line, don't overthink. The whole gradient of the same straight line must be the same. The whole thing. So you don't have to break it up. Q, R, S, whole thing, all the same. Yeah, so it won't be like this. It won't be like C. Answer is boy. Okay, which makes sense, guys. Why do we say the gradient will give you the velocity, or so you think? Why do we say this is a positive velocity? It means that at first, Mei Mei is walking further and further and further away. From 0 meter, walk to 100 meter. You're walking further, 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 further. Okay? Or maybe I draw this for you. From 0 meter, she walked to 100 meter. And guys, if you walk, you will have a certain speed, right now. Okay, so she walked there. And then afterwards, she stops here. She never moved. At 100 meter there, she just stand there. She stand there from 100 seconds to 150 seconds. She just never moved. She just stood there, never moved. Now, Mimi is going to start slowly walking back from 100 meter, walk to 0 until reach -50, which means she will slowly walk back until here. Negative displacement just means that she will pass her starting point and go over to the left side like this, for example. So the whole journey is from 0 to 100, then rest there. From 100, come back to -50. Okay, a velocity to the right, we normally call it, or forward, we normally call it positive velocity. Then go backwards, we call it negative. So the positive, negative represents her direction. Go forward and go backward, or go to the right and go to the left like that. Okay, answer is boy. Okay, question 5. The diagram 3 shows durian falling from a branch with a height of 5 meters. What is the velocity of the durian just before it hits the ground? At first, durian never move. Now, durian will become faster and faster and faster. We are looking for right before you rest there on the ground, what is the final velocity? The 5 meter here sounds like S. And then also, when you drop something down, the acceleration is 9.81. Normally we call it the acceleration, or you can call it the gravitational acceleration. You can call it the G value. This is your classic SUVAT question. S-U-V-A-T. SUVAT. Okay, this is how I teach my students. S is 5 meters, U is 0 meter per second. I want to find the V. I have an acceleration of 9.81, or if you like to call it a G, also can. But we don't have the T. You go and look at formula sheet. You find something, right? You don't have T, and I don't want to find T. I don't have T, I don't want to find T. I don't want the T. I don't have it. All the formula with T you cannot use. So you use formula number 4. V squared equals to U squared plus 2AS. Okay, you can find this in your SPM formula sheet. Okay, so we will use this. This formula very good, don't have T. There's always one symbol that you don't want or you don't have. Yeah, because all the formulas for SUVAT can only deal with 4 symbols. Like for example, S, U, V, and A. 4 symbols only. And you want to call this a G also can, up to you. Same thing, huh? Okay, so U is a 0, A is 9.81, S is 5. 0 squared is just 0. Everything multiplied together, 98.1. Don't forget to square root your answer. I get 9.904 on 9045. something. Okay, rounded off, it will be A. A is the answer. Okay, question 6. Diagram 4 shows a rocket taking off from the surface of Earth. What is the factor that influenced the escape velocity so that the rocket can take off from the surface of Earth? For this one, you go and look at the escape velocity formula. The problem is there are a lot of formulas with the symbol V. This one is V, this one is V, this one also V. Yeah, so SPM is like that. I will give you formula, but you need to know which formula is which. Number 10 is called escape velocity. Number 9 and number 5, they are the same. They are called linear speed. Okay, if you want to find out the speed of the satellite moving, how fast the satellite is moving when it's orbiting Earth and all, I use this formula or this formula. Usually we like number 8 more. Okay, number 8 is the more common one. But number 10, if you see the extra, this one got the extra 2 in front, this one don't have the 2. I always tell my students, got the extra 2, the value is bigger one. For you to escape, you need a bigger value. That's why I got a 2 there. Yeah. This one is the escape velocity. So going back to the formula, V is equals to square root 2gm over r. The mass of rocket is what you call as small letter m, not the big letter M. Whatever I wrote here is big letter M. You must know the difference. If Earth is at the center, and Earth is damn big, we call Earth as the mass big letter M. The satellite is very small. The one that is smaller, small letter m. Okay, so it can change one. Like for example, let's say I got sun in the middle. Sun is big letter M. Earth that is orbiting the sun, Earth is smaller. Then Earth would be small letter, right? So don't always memorize Earth has to be big letter. It can be small letter also. So it depends on what 2 object are you looking at. The one with a bigger value, bigger mass, big letter. Smaller value, smaller mass, small letter. Okay, so A is wrong. Mass of the rocket and the Earth are wrong. Only the mass of the Earth. Distance of the object from the center of, distance of the object from the center of Earth, that's R. Okay, that sounds correct. Distance of the object from the surface of the Earth, this one wrong. This one is called H. Answer is C. Now, those of you who are thinking, teacher, what is the difference between R and H? H is the height. Let's say your satellite is here. Let's say this is called height from the surface of the Earth. We always call it H. But you always need to use the distance from here all the way to the center of the Earth. That is called small letter r. Must know the difference. Okay, so this is checking on how well do you know the symbols. Yeah, number 6C. Number 7, which of the graph shows the correct relationship between G value and R? Okay, the answer is B. This is a graph that you need to know. Yeah, this is a graph that you need to know. Let's say you are talking about Earth. By the way, if I ask you, can you go and label what is this value? This value is called 9.81. Okay, and also, they say R is the distance from the center of Earth. From the center of the Earth all the way to the surface, you have the radius. Right now, center of the Earth until the surface of the Earth, that's the radius of the Earth. Radius of Earth, we call it big letter R. Which means, when I say big letter R like this, it means that here is the surface. Earth's surface. Okay, then what does 2R means? 2R means you leave the Earth's surface. You leave the Earth's surface and the distance now is 2 times the R. And you go further and further and further. Guys, as you go further, the graph must fall down. This graph, this part right here, comes from this formula that you see they wrote at the side. It's supposed to be small letter r squared, where the further you go, the smaller the G value. Makes sense lah. If I go further, the gravity is weaker, right now. You leave the Earth already. The further you go, the weaker the gravity, the smaller the G value, that's for sure. And it's gonna fall down in a curved shape. It won't be a straight line like this. Okay, it won't be a straight line. Now, inside here is always directly proportional. You start from the center of the Earth and you go closer and closer to the surface, the G value will get bigger and bigger and bigger and bigger in a directly proportional shape. They won't really ask you much about this. They won't ask to calculate or anything, but in your syllabus, you're just required to know the shape of the graph in front here. Okay, the green color part here, they can ask you to go and calculate the G value and all when you leave the surface and you go further and all that. Formula given. Okay, question 8. Which of the following is the characteristics of non-geostationary satellite? Direction of rotation is same as direction of Earth's rotation. Actually, A has a little problem because they say direction of rotation. This is supposed to be direction of orbit. It's same as direction of rotation because why? We don't really care about whether the satellite is rotating. What we care about is how the satellite orbit. You must know the difference, huh? The Earth will rotate 24 hours, but the Earth will orbit the Sun for 365 days. Rotate and orbit is different. Okay, so by right is supposed to be the satellite orbit same direction as Earth rotation. That one is for geostationary, but this one they want non-geostationary. Let's see if there's any better answer. Orbital period can be more or less than 24 hours. Correct. For non-geostationary, yes, that's right. Can be more or less, but cannot be 24 hours. If 24 hours, it is geostationary. Used as communication satellite through whole world to communicate. That one is geostationary. Position of satellite is always above same geographical location. This one, geostationary. Okay, best answer is boy. If they never say boy is the answer, if boy is not here, then I will choose A actually. A is also non-geostationary, if you ask me. Okay, the second best answer. There is an error in the question actually. They're supposed to write orbit because the satellite don't really rotate that much. Or we don't care about its rotation to be frank. Whether it is non-geo or geostationary does not depend on how they rotate, but how the satellite orbit the Earth. Is it always following the same geographical location? Let's say the satellite always on top of Kuala Lumpur, and as the Earth rotate is always right on top of it. That is what we care about. Okay, so a little bit of a flaw on this question. Number 9. A long jump athlete with a mass of 54 kg has reached a distance from a takeoff point. What is the gravitational force between the athlete and the Earth? Okay, they give you all these values. Guys, I'll give you two ways to do this. I know that they gave you distance from center of Earth and athlete, mass of Earth, G value and all. So naturally, we would think, all right, mass of athlete is called small letter m. Mass of Earth is big letter. It's much, much bigger. We also have the distance. Then you go to your formula sheet. The classic Newton's universal law of gravitation. Okay, F equals to G m1 m2 over r squared. Okay, so let's try. You can call it m1 m2 or big M small m also can. And then you would sub in. So 6.67 times 10 power negative 11 multiplied by 5.97 times 10 power 24 multiplied by 54 divided by 6.37 times 10 power 6. Don't forget to square. Yeah, be careful with that. Okay, calculator time. You get 529.926. Okay, which is the same as C. Okay, if they round off a little bit, 500, around 530 newtons. Right. But you know what, guys? Can I give you a trick to deal with this question? I want to ask you a simple question. When an athlete is doing long jump on Earth, okay, when an athlete is doing long jump on Earth, he's not very far away from Earth. Would you agree that the G value, the gravitational acceleration on Earth, should be around 9.81? Okay, should be around 9.81. Can I just say, to find the gravitational force, question asks, what is the gravitational force? Can I say, if I want to find gravitational force, it is the same thing as weight. Do you know that? Exam or SPM has asked many times, what is the meaning of weight in paper 2? And we always say weight is gravitational force. I think 2021 SPM paper 2 also got asked in the essay question, what is the meaning of weight? Weight is gravitational force. So if I ask you to find gravitational force, you know the G value because it's just on the surface of the Earth. Can I just say that weight is equals to mg? So can I just say, if his mass is 54 and the G value is 9.81, multiplying them together, I'll get 529.74 newtons. So for objective question, I can do like that, no problem. It's very, very similar, the answer. Okay, why this one a little bit different is because mass of Earth, actually the decimal very long one, but then they round off. And then the distance also is very long one, but then they round off. Yeah, so because round off a bit here, round off a bit here, the answer is a bit affected. But if you ask me, actually the blue color one is more accurate. In real life, the blue color one is even more accurate. Okay, so just to let you all know, just to remind you, sometimes you can be creative in the way you think, especially in objective, because no one care about how you get your answer. Right? So number 9, answer C. Okay. Yeah. Number 10. Diagram 5 shows a Y-shaped slingshot used by a student in an experiment to determine the value of V squared of different mass of stones. Okay, we're conducting an experiment to figure out V squared and M, velocity of stone, and also mass. The relationship of the variables in this experiment is given by this, Fd equals to mv squared. F represents the force of how hard you pull. And D represents the extension distance. Okay. Which statement is correct about this experiment? The gradient of V squared against 1 over m is equals to F. Now, or maybe before we do this experiment, actually this is a chapter 1 question, from 4 chapter 1. Seeing how well do you deal with your variables. Mass is your manipulated variable. Velocity of stone is your responding variable. So I change the mass of the stone, and I'm going to see how fast the stone will move. Considering that my force and my extension should be constant variable or fixed variable. Okay, because questions say I use this experiment to determine value of speed or velocity for different mass of stone. Who is the MV, who is the RV should be very clear. Yeah, so gradient of V squared against 1 over m is equals to F. Well, you know how to figure out. V squared against m means this is y-axis, this is x-axis. Okay, whenever people say gradient, right? Usually gradient is you take y2 minus y1 over x2 minus x1. So like this, okay? And then you take your y value divided by your x value. When you divide by 1 over m, divide by 1 over m is the same as multiply with m over 1, which means your gradient is v squared times m, which is not the same as the value of f. Why? Because the equation is fd equals to mv squared. So I'm going to write it down here. Okay, mv squared is the gradient, which means the gradient, you can either call it mv squared or you can call it fd. Answer is that the value is not f, it's fd. That's why it is wrong. Okay, it is wrong. It's supposed to be fd. Okay, A is wrong. B, the velocity of stone increases as the mass of stone increases. How do we know whether the velocity will increase or decrease? Well, you have to check the formula and the relationship. Maybe I use a different color. Okay. In Form 4 Chapter 1, I always teach my students this. If you want to figure out the relationship between M and V, let's say, you can always move them to different sides of the equation. Like, let's say, you divide the mass come down here so that M is on the left side of the equation, V is on the right side of the equation. And if you see that one of your variables is at the bottom, one of your variables is at the top, it means you get kind of like we call this an inversely proportional relationship. M and V squared is inversely proportional. The greater the mass, the lower the velocity, which makes sense. If I throw a heavier stone, I think the stone will move slower, not faster, right? So the velocity should decrease when the mass increase. Answer is boy. Boy is also wrong, my bad. Yeah, boy is also wrong. Then C, the product of FD is always constant for different mass of stone. Okay. Product of FD is always constant. Yes, it's always constant. So F multiply with D, because when you multiply your, since these two, they are constant variables, so every time you multiply F and D together, it will always be a fixed number. That's what it means, a constant value. Even if you change the mass of your stone. Yeah, you can be changing different mass of stone. It will always be fixed. Then you might be thinking, teacher, I don't get it. How come when, let's say, the mass increase, how come this FD will always be constant? Always be fixed? That is because as you increase your mass, your velocity will decrease. And you multiply them together, they will balance out each other. They'll balance out each other and always give you a fixed number. Let's say you multiply the F, the force, and the distance together, you always get a number that is called a number 15, for example. So you make the mass bigger, you use a bigger stone, bigger mass of stone, very heavy stone, but then at the same time, its velocity will drop. You multiply them together, it will still give you 15. You use a lighter rock, but you use a lighter stone, the velocity will increase. They will still balance out each other. You multiply them together, it will still give you a 15. So no matter what, FD is, if it's a constant variable, you multiply them, it won't change. Even for different mass of stone. The answer is C. Yeah, this question is pretty tricky. It depends on how good you are with all this formula and variables, but it is a very good question. Okay, lastly, D, as F increase, D decreases. How come this is not a good answer, even though we say, okay, let's say, remember I say, you're thinking about how, if let's say I want to find the relationship between F and D, maybe you go and move F or D to the other side, and then you can see F is on top of the fraction. F is F divided by 1. So you might think like, oh, F increase, then D will decrease like that. Oh, that's why this is wrong also. Yeah, that's why this is wrong. But from this formula, you might be thinking it's going to be increase, decrease. Even if they say 1 increase, 1 decrease, I still won't choose D as the answer. C is still the best. You know why? Because in this experiment, F and D, the force and the distance, they are constant variable. So by right, they shouldn't change. Based on this experiment, they shouldn't change. What should change is the mass and the velocity. Okay? Right, so quite a tricky one. Best answer C. Okay. Question 11. The diagram shows an empty plastic bottle placed in a refrigerator. After a few minutes of cooling, the plastic bottle dent. After a few minutes of cooling, that means temperature drop and then it will dent. When the bottle get crushed, it means that its volume decreases. Okay, the decreasing of temperature will cause what? Air molecules distance to decrease. That's correct. Why? Because when temperature decrease, kinetic energy of molecules decrease. When the molecules they decrease in kinetic energy, that means they don't move so fast, lower velocity. They would hit the bottle less hard. Okay, and so now the molecules are going to force to get closer and closer and closer together. You know how hot things will expand and cold things will shrink in size, get smaller. Molecules will slowly squeeze together, become closer together. Air molecules distance decrease. Kinetic energy increase is wrong. So answer is A. And then C, rate of collision increase, also wrong. Because you are less excited, less kinetic energy, so you will collide less. Okay, number of air molecules is unchanged. Won't change. The air cannot escape also. How will the number of air molecules change? It's the same bottle, same number of air molecules. Okay. If they ask you which gas law this is Charles' law. Yeah, this is Charles' law, where the pressure is constant. Question 12. The table shows specific latent heat of fusion and the amount of heat released by 1 kg of substance RST during solidification process. They want to do fancy name. Maksud solidification is freezing. Same. Don't worry. Okay, so we got different latent heat of fusion. They ask which comparison of heat release during solidification is correct. Okay. This question is just asking, do you understand the meaning of latent heat? If I say your latent heat of fusion is this much, it means what? You need, substance R requires 339 joules of heat energy for 1 kg of substance to change from liquid to solid. Okay? Substance S needs to release 334 joules of energy for every 1 kg of substance to change from liquid to solid, to freeze up. And then substance T requires less energy to freeze. So the heat released for Q is the highest. T is the lowest. So it's R is the highest, then followed by S, followed by T. Okay, R would need to release the most, then only can freeze totally. Okay, question 13. The diagram shows, set up apparatus to study the effect of resonance for Button's pendulum. Based on the observation, which of the following statements is correct? Okay, we go and find first, which one is the one that will be in resonance? It will be K. K will be in resonance. Why? Because K and X, K and X, they are same length. Because they are same length for a pendulum, when you have a same length pendulum, a pendulum will naturally want to swing at a certain frequency one. We call that a natural frequency. So not only they have same length, they have same natural frequency. They like to swing a similar way. So when let's say let's say let's say you swing X, sorry. You swing X, K will swing the highest. Okay, J, L, M also will swing a bit, but K will swing the highest because X and K, they are swinging, they like to swing the same frequency. Naturally, this pendulum with the same length likes to swing at a very, very particular specific frequency. As you swing X, you will swing this string on top. The string will cause the oscillation of all the others. Okay, let's see which one is the best statement. J oscillates faster because it has a shorter length. Not really. I want to look for the best observation for my experiment. K will oscillate at maximum amplitude. That is spot on. Maximum amplitude is the keyword. It will swing the highest. Amplitude is how high can you go. The maximum displacement you can go. Yeah, because its natural frequency is the same as X. That is correct. Whatever I just explained, right? But let's see C. L oscillates faster because it absorbs energy from the other pendulums. L, no lah. Then M oscillates at maximum amplitude because energy absorbed is maximum. Okay, that's also wrong. Okay, best answer, boy. Okay, K and X, same length, same natural frequency. Okay, question 14. The diagram shows cross-section of a ripple tank when water wave moves from region A to region B. What is the variable that causes wavelength decreases? As you go to a shallow region, the depth decreases. When the depth decreases, your speed will decrease, and as a result, your wavelength will decrease. Okay, so putting a glass plate there makes the depth decrease, and so I think they also purposely draw the lambda will be a bit shorter. At first, deep region the lambda is bigger, and then shallow region the lambda is smaller, shorter. Okay, so what changes the wavelength? Either the answer could be speed or depth. Frequency will change or not? No, frequency will not change. That is very important for refraction. This is a refraction of waves. Huh? That is to understand that the frequency won't change. If here, let's say it's 2 Hertz, here will also be 2 Hertz. Frequency won't change. Because it comes from the same water source. It's the same water. The frequency should be the same also. Okay. Question 15. Bluetooth is a wireless technology with a frequency range of 2.4 gigahertz to 2.48 gigahertz. Okay, Bluetooth. Used to send data between fixed and mobile devices over short distances. Based on the above information, Bluetooth is a type of... A lot of people thought answer is A. Maybe even some teachers, I'm not sure. But it cannot be sound wave. Guys, Bluetooth where got emit sound one? Bluetooth is an electromagnetic wave. Electromagnetic wave and sound wave different. Sound wave requires a medium to travel. Yeah. If I talk in a vacuum, you cannot hear me. But Bluetooth must be a type of electromagnetic wave. So must be either your radio wave, microwave, infrared, one of those. Visible light, ultraviolet, all those. Yeah. And the answer is boy, microwave. Infrared is normally when we use for remote control. And ultraviolet ray normally we use to let's say to detect fake fake notes, like how to see whether the 50 ringgit or the 100 ringgit is real or fake. We can shine some UV to detect your fake notes or to detect counterfeit notes, we call it. Or sometimes ultraviolet ray can also be used to kill a lot of bacteria and germs. Let's say that's why we like to sun our clothes, sun our baju in the sun. Because sun got a lot of UV ray, ultraviolet ray. It can help to kill the germs also. Yeah. But guys, Bluetooth is microwave. They mention like short distance and all. Something that is not very, very high frequency like infrared or ultraviolet. Okay, so this one you need to know a little bit of the application. If don't have microwave, you know which one I would choose? I would choose radio wave. A lot of Bluetooth, they are either in the radio wave or the microwave range. Frequency don't need to be too high, around radio wave and microwave. So microwave is a bit stronger. Radio wave is a bit weaker. We see lah what is the purpose of the Bluetooth that you need. Yeah, but most of the Bluetooth is microwave. Okay. Definitely not ultrasound. Okay. Number 6. The diagram shows object placed 10 cm in front of a concave mirror of a focal length of 5 cm. What are the characteristics of the image form? Well, a concave mirror has a very similar image characteristics to a convex lens. The image very similar. Right now, you're putting your object exactly at 2f. It will give you real inverted same size. How do I know? Well, there are two ways. Either you go and draw, yeah, either you go and draw, or you you remember or you memorize the characteristics of convex lens. Yeah. So for convex lens, normally we say if here is your lens, here's f, here's 2f. Or you can even put your object at infinity. If you put your object here, you're going to get real inverted diminished. If you put further than 2f, it's real inverted diminished. If you put here, it is real inverted same size. If you put between f and 2f, it's real inverted magnified. Here, virtual upright diminished. Virtual upright magnified. Here, closer to f, virtual upright magnified. Right now, it is this. Real inverted same size. Answer is A. Okay, this is why some students, they memorize read, ris, rim, voom, voom. Up to you. You want to memorize, then you can answer this kind of question very fast. If you don't memorize, don't worry, guys. There is a picture, right? Not. If you are given a picture, maybe you can go and draw. So I'll move this away first. Okay. And then, guys, because the mirror is too very, very curved, I think I go and draw a dotted line like this. Like if I follow the curvature of it, I think my drawing will be very ugly, or it will look a bit off. So sometimes we'll go and draw this line. We call it the axis of the mirror. Yeah, where normally how do we do drawing? Straight ray. If you got a parallel light ray, go to the mirror here. Why I don't draw to the curve again? Because if I draw to the curve, a lot of the time it will look very chacha since the curve. This one I feel like the curve is not drawn properly. They simply draw one. Yeah, so normally you can draw a dotted line. It's optional. I feel you will get your answer better, and then it will go and reflect to your focal point somewhere here. Then if it passes through your focal point, okay, when it reflect, it will become parallel. Okay, wait, this one, somehow I cannot really draw nicely. Okay, something like that. Okay, I'm just trying to show you roughly. Okay, I know here a bit chacha, but somehow I cannot put it right in the middle. I don't know why. Okay, but basically this is what you get. This is a real image and a terbalik image. Just now your object is standing up. Now your image is pointing down. And remember, when you do a mirror, the light ray must reflect. And it is exactly the same size as the object. Why? Because the object and image distance is the same. If you have the exact same distance, it is the same size. Okay, so if you memorize this, you can answer straight, or you can do the drawing also. Okay, question 17. The diagram 10A and 10B shows ray diagram of convex lens with the same focal length in a camera which produces height h1, h2. Everything the same, just that the object distance different, which creates a different height of image. Okay. Which relationship is correct? As the object distance decreases, they ask you about object distance and also height of image. Height of image, they call it like this. Okay, height of image. As the object distance decreases, the height of image increases. Do you notice? The height, how high this image looks is going to increase. Oh, they call it H. Sorry, just H. Okay, so I must find a relationship that one go down, one go up like that. One decrease and one increase. Decrease and then increase. Okay, I think the best answer is donkey. If I couldn't find one decrease, one increase, then I will go and find the other way around. One go up, one go down. Right? So if this one increase, then the other one must be decrease. You get what I mean? Must be one up, one down, basically. So that's why question 17 answer is donkey. That's the only one. Yeah. Object distance. Oh, I'm so sorry. I just noticed something. I put your object distance wrong already. I made a mistake just now. Object distance supposed to be all the way until the lens, not until F. My bad. Sorry. Okay, all the way until F. But it is still shorter. The shorter the object distance, the bigger the height of the image. Just from this experiment. Don't overthink it. Question 18. There are two diagrams, A and B again, showing the image from a camera lens from the same focal length. Which pair of position of an object is correct? Okay. Actually, you need this. First of all, a camera lens uses a convex lens, which means it is this characteristics. Guys, convex lens is this characteristics. Just now, concave mirror also is following these characteristics. Okay, how come the first picture so big one? I think because the first picture is all the magnified one. Should be all this. Okay. Why this picture looks like very zoomed out, a lot smaller, a lot diminished? Oh, because I think maybe this one is all the diminished one. So you notice a trend. If your object is further, then it will be diminished. If your object is closer to the lens, then it will be magnified. So your A, to get magnified, it must be closer to the lens. Diagram A, you must look for all the answers that are closer to lens. Diagram B, you must look for all those that are further from the lens. Okay, further away. So one closer, one further. Okay, if this one is equals to 2F, this one cannot be closer than 2F. Yeah, F, between F and 2F, meaning it is right here, between F and 2F. So it cannot be that. Okay, if this one is greater than 2F, if this one is close, oh, this one is already very far away from the lens. Greater than 2F, meaning right here. This one cannot be closer. Okay, so that's wrong also. And then next one. This one is very far away from 2F, but I want closer to the lens. I don't want so far away. But this one very, very far away. And then this one is a bit closer, which is wrong. I want the one that is a bit further. I think answer is going to be donkey. This one is right here, closer to the lens. This one is further away from 2F, right here. Okay, diagram A closer to lens. Yes, memang closer. Diagram B further away from the lens. Answers donkey. This question is very kebat. I feel. If you're not good with the characteristics, you won't be able to answer this. Okay. Question 19. The diagram shows a graph of image distance against linear magnification. X is represented by what? Okay. Linear magnification, if you look at your formula sheet, is given by this. Also, my bad. Also, if they say they ask you to draw a graph between V and M, you might be thinking, oh teacher, I just look at this formula, is it? Can also, you need to understand that this formula can never ever give you a graph that looks like this. Why? Because this graph is a graph that has a gradient, a graph that has a y-intercept. Can this give you a gradient and a y-intercept? It can never. It can never give you a gradient and a y-intercept. Even if you're thinking, teacher, let's try and see, because this is my y-axis, this is my x-axis. Maybe I can write it as y equals mx plus c, right? Maybe I'm thinking about this one, I want to put y-axis, this one I want to make it as x-axis. So you multiply the u and you leave the v alone. V equals to mu, like this. And so you're thinking, if this one is the y-axis, this one is the x-axis, this one is the gradient. The gradient is going, oh, I'm so sorry. Terbalik. My bad. Sorry. Instead of mu, I'm going to write it as um. Because the m is the x-axis, the u is the gradient. Okay, don't get confused. This m is called gradient, this m is called magnification. But then the problem is, do you notice this graph has a c value? But right now your c value is 0. So it cannot be just coming from here. Okay, this question is actually pretty kebat. Other than this formula, what else? In your formula sheet, there is also another one that has a lot of U and V. That is formula number 5, your thin lens formula. Yeah, so actually this one comes from your thin lens formula. This one very kebat also. Where I will say 1 over F equals to 1 over U plus 1 over V. Guys, your goal is to try to make V as the y-axis, M as the x-axis. Remember that. Now, how to do this the fastest way is, remember, M is equals, how to get M? M is equals to V divided by U. V divided by U. Okay, so if I multiply everything by a V, this is what I will get. V over F, V over U, V over V. Okay, and so when you see a V over U, what does that mean? It means it is a gradient. You can substitute a gradient as V over U. So now the equation looks like this. And V over V is just 1. Right? V over V is just 1. Okay. At last, I want to write it as y equals mx plus c. My y-axis is a V. So what you do is, maybe you multiply F, or maybe you just, sorry, I do an easier way lah. Maybe you just multiply F to that side. So that you get F M plus F. Everyone multiply by F. And guys, you're done already. This is the y-axis. This is the gradient. This is the x-axis. And this is the y-intercept. X is actually the focal length. The gradient of this graph is also going to give you the focal length. Yeah, a pretty hard one, this one. A bit unfair if you ask me to ask SPM students this, because you cannot find this in the textbook. Okay, question 19. X is represented by the focal length. A lot of people, I think, will timba object distance. Yeah. Okay, question 20. Diagram 13 shows a construction worker who is pushing a trolley with a force of 500 newtons at an angle of 60 degrees to the floor surface. What is the net force exerted to the trolley horizontally? Okay, they're asking, if I apply a force of 500 newtons like this, okay, what is the horizontal force? Okay, when you push a trolley like that, some of the force will be pushing the trolley forward horizontally. Some of the force will be pushing some of the force will be pushing the trolley downwards vertically. Horizontal and vertical. Right now, we are looking for the horizontal. Okay, and the horizontal force is equals to, maybe you move your angle a bit, huh? The 60 degrees can come over here. Okay, 60 degrees can come over here because of your Z shape. In maths, you'll learn that if you have a parallel line, this is what you call as an alternate angle, right now. Here 60, then here 60 degrees. Okay, Fx is equals to 500 cos 60. That would be the answer. 250 newtons. How do you know? Is it cos or is it sine? Like, because this one is 500 sine 60. It depends on your which way are you going. So let's say if 500 Newton is going closer to Fx. To get closer to Fx, you need to go closer to the angle. 500 go closer to the angle. 500 go closer to the angle. Cos means you are going closer. This is how you should remember it. The 60 degrees on top here, 500 Newton is going closer to the angle. You must draw the angle right here one. You must know where the angle right here. Okay, 500 go closer to 60 degrees. If 500 Newton is going further away from the 60 degrees, 60 degrees on top, but the 500 Newton is going further and further and further and further away until you reach the Fy. Going further, going away. Then you use sine. So sine is away. Cos is closer towards the angle. The angle is here, you go close to the angle. Or the angle is here, you go away from the angle. That will be sine. Okay, that's question 20. Okay, question 21. The diagram 14 shows two wagons, R and S, are pulled with the same force. In the period of 30 seconds, the distance traveled by R and S is 5 meter and 2 meter. 5 meter, 2 meter for a period of 30 seconds. Okay, which of the following statement is correct? It looks like they are talking about a lot of the time, mass and acceleration, velocity and acceleration, and also mass and acceleration. So it looks like it has something to do with acceleration. Okay, but looking at this picture, it looks like the reason why this one moved less distance is because probably it is heavier. When you are heavier, your acceleration will decrease. When your mass is smaller, you're lighter, your acceleration will increase. And guys, this comes from your Newton's second law of motion, F equals to ma. Assuming you, no, don't need to assume actually. They say I apply the same force. I'm pulling with the same force. When force is the same, the relationship between M and A is always inversely proportional. Greater mass, smaller acceleration. It's always one go up, one go down. Very logical one. Heavier confirm won't accelerate that much. So I'm going to look for this answer. Increased mass will increase acceleration. That's wrong. I think the answer is donkey. Decreased mass, increase acceleration. Okay. But let's quickly look at B and C. I don't think this is a good answer because this is dealing with velocity and acceleration. Okay, when velocity drop, acceleration will increase. No, that's weird. The more you accelerate, the faster you should be, greater velocity. Increased velocity will decrease acceleration. Also false. That's very weird. The faster you are, more acceleration, more velocity, right? Okay, question 22. The diagram shows the weight of an object, 1000 Newton, being pulled by a force of 850 newtons through an inclined plane with an angle of 30 degrees. Frictional force acted on the object is 150 Newton. What is the resultant force acted on the object? Okay, so resultant force would come from any force in this direction. Why? Because the object is going to either move up or down. Okay, I think it's most likely going to move up because you are pulling it. So resultant force can only come from everything that contributes to acceleration. Remember that. According to your F equals to ma, guys, please don't always think that F is just a normal F. This F always is the resultant force equals to ma. To get an acceleration, or rather, maybe I put it this way, the acceleration is always related to the resultant force. The resultant force related to the acceleration. So who gives you resultant force? They are the ones that also give you acceleration. Now, 850 confirm will contribute to the acceleration. 150 Newton friction force confirm will contribute to the acceleration. It will make it slow down, pull it back. But another thing, when you have a block like this with a weight of 1000 Newton, some of this weight will cause it to move downwards. That's why sometimes you put something on a slope, it will roll down on its own because there is this force. There's also this force. Okay, Ken? And if I ask you, which of the force is the one that I care about? I care about this. I don't care about this. Why? Because a force pointing down like that can never affect my acceleration going up the slope. Right? If I pull you down, will your block ever accelerate like this? These two has no relationship with each other at all. Pulling something down would never make it accelerate up or down. So I don't really care about this. It would not affect the resultant force. You just care about everything along this line. Okay, now the question is, how do you split your 1000 Newton to these two blue color one? You need to know that the 30 degrees will come here. If you have done a lot of exercises on this, you will know why, right? But those of you who don't know, let me prove to you why. That's because if you look at this tiny triangle in here, this is a 90 degree, and hence here will be 60 degrees. 180 minus 90 minus 30. So here 60. If that is 60 and this is a 90 degree, this has to be 30. Okay, 90 minus 60 equals to 30. Now, you can call this, normally we don't use the 60 degrees. Normally, exam questions, we like to use the original value of 30. Okay, can I rub this off? I don't want to make it too messy. Normally, we like to use the 30. But if you say, teacher, I really like the 60, can I use it? Go ahead. It's also correct. But up to you. I like to use 30. Marking scheme likes to use 30. Because 30 is the value given in the question. Which means this is 1000 sine 30. If you want to know what is this is 1000 cos 30. Anyone think of using the 60 degrees? Also can. This is 1000 cos 60. They are the same thing. Up to you which one you want to use. Okay, I'll rub off. But you type in your calculator, they will give you same value. I'll rub off this one. I don't want to confuse you. Okay. Again, how come sine and cos? Like just now, the previous question, 1000 go further and further and further away from the 30 degree. You must label the angle here. Don't look at this angle anymore. You must label the angle here. 1000 Newton, go further, 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 further away from the 30 degree. 30 degrees here. Go further, 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 further. Or 1000, go closer, 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 closer. Go closer is cos. Go away is called sine. Okay, so focus on everything that is going up or down the slope only. this one, this one, this one. To find the resultant force, everything go up, I will minus with everything go down. So 850, I'm going to minus with 1000 sine 30 and also 150. I'll get 200. Or if you want to calculate what is 1000 sine 30 first also can, that would be 500. Okay, so you can also say, teacher, can I do 850 minus 500 minus 150? Can also. Or you want to put a plus and put bracket like that, up to you. Okay, it will be the same, 200. I wouldn't say this is hard, but it will be hard if your understanding on this topic is weak. Yeah, this is a pretty, it's one of the harder questions, but you can find something like that in the textbook. Okay, it's not like super kebat. Question 23. The diagram shows a barometer placed in an underground mines. What is the atmospheric pressure in the underground mines? Okay. Answer for this is 90 cm Hg. Done. Just know that here is the atmospheric pressure acting on the surface. Okay, the atmospheric pressure must be the same as the pressure of the mercury. We say that point 1 and point 2 must always have the same pressure because they are always the same level and they're the same liquid. Both must be mercury, both must be same level, then they will have the same pressure. The pressure here is P80M, the pressure here is 90 cm Hg. P1 is called P80M, P2 is called 90 cm Hg. 90 cm of mercury. What about the 10 cm? Guys, vacuum has no pressure. Has no pressure. So you don't have to worry about the vacuum will press on the surface or don't need. Vacuum is, there's no air. There's no air means there's no pressure. 0 Pascal. Huh? 0 Pascal. Answer is C. Question 27. The diagram shows two aquariums with different shapes filled with water and the same level. The pressure on the fish is influenced by depth of the fish. Yeah, pressure, the liquid pressure on the fish is not depending on the diameter, the mass and all. Why? Because liquid pressure depends on three things only. This formula you can find in the formula sheet. This one. Okay, that is for liquid pressure. And it depends on the depth, how deep you are. It depends on the density of the water. It's the same water. And it depends on the G value, whether you do the experiment on Earth or not. Volume not affected, mass of fish not affected, diameter of quantity not affected. You can have a very big volume, it doesn't matter. Okay, those of you, those students who are weak, they see the picture, they thought, oh, volume of water different, they went circle A already. Or they see the mass of the fish different, then they circle B. Yeah, those are not the answer. Look at the formula, you will get the answer. Okay, Ken, question 25. The diagram shows a hydraulic jack. The pressure exerted on R is this. Okay, what is the maximum weight that could be lifted by the large piston if it has a surface area of 200 cm squared? Now, if your pressure is 150 Newton, by the way, they purposely use cm squared to help you because here is also cm squared. Okay, and if your area is 200, now Pascal, by the way, this hydraulic jack model is Pascal principle. In Pascal principle, we say that the pressure transmitted in the hydraulic fluid will always be the same. In the whole hydraulic fluid will always be uniform, will always be the same. Okay, pressure transmitted is always uniform throughout the whole liquid, which means the pressure here is the same as the pressure here, is the same as the pressure here, is the same as the pressure here. Okay, so even if I talk about the surface area here, the pressure here, don't need to worry. Yeah. Now the question is asking, what is the maximum weight? How heavy can you put? They're asking you for the force. You do pressure equals to force over area. Formula given again. Let's take a look. Pressure equals to force over area. 150 Newton per cm squared equals to F divided by A. Okay, you multiply these two. Don't worry about the units because why? They get cancelled eventually. I purposely wrote it to show you. And you will get the answer as 30,000 newtons. Okay, 30,000 newtons. Answer is donkey. If the force that it can withstand is 30,000, by the way, according to forces in equilibrium, if you can tahan, I can supply 30,000, it means that maximum your weight can also be 30,000. So maximum weight is the force. Okay, answer is 30,000. Question 26. The diagram shows hot air balloon with a mass of 250 kg. Buoyant force is 2,400 newtons. Weight is 2,500 newtons. Okay. What is the acceleration of the hot air balloon? To find acceleration, the reason, by the way, the reason why there is an acceleration is because if you look at these two forces, they are not in equilibrium. One of the force is pulling harder. The weight is pulling more. The weight is stronger. So you use your chapter 1 knowledge to find acceleration. You use resultant force equals to ma. How to find resultant force? You take the bigger force minus the smaller force. Always just take big minus small. Now the weight pulling harder minus the 240. Mass is 250 kg. Then you find acceleration. You minus, you get 100. 100 divided by 250 is the acceleration. You get 0.4. Okay, that means it will slowly, because by the way, the weight is pulling harder, the weight is stronger. That means this hot air balloon will slowly accelerate downwards at 0.4. Okay, can. Question 27. The diagram shows arrangement of apparatus to describe the behavior of charged objects in an electric field. The metal-coated polystyrene ball touched the positive plate. The frequency of oscillation of the polystyrene ball increased when? Okay, so the idea is we purposely use a polystyrene ball because very light, but we coat it with a metal so that it is a better electricity conductor. Now, the moment it touches the positive plate, the ball will become positive. But positive and positive will repel. So it will push the ball over to the other side. But then when the ball touch the negative plate, it will become negative. Negative, negative, repel again. So it will keep on pushing the ball left, right, left, right, left, right, left, right, like that. Yeah. The reason why this happens is because you have a very strong electric field between the two plates. Okay, so you want it to swing faster means you need to have a very strong electric field. Think of how to make electric field stronger. I don't think increasing the thread will make a difference. If the ball is heavier, then it will move slower because harder to move, very heavy. If you increase the distance of the metal plate, of course the electric field will be weaker, right? But if you increase the potential difference, stronger voltage between the two plates means stronger potential difference, stronger voltage, you will have a stronger electric field as well. Actually, there is a formula that deals with this situation that is, let me show you this one. E equals to V over D. The electric field strength equals to voltage divided by distance. How strong is your electric field? Electric field strength. You want stronger electric field, you increase the V. That is donkey. Okay. They say increase the D. Why is that wrong? Because if you increase the D, then the E will fall down. So that's why C is wrong. Okay, C is wrong. Question 28. The diagram shows two electric circuits, A and B, consisting of identical dry cell and light bulb. The connecting wires are made of the same material, same length, but different thickness. So everything the same, just the thickness different. The bulb in circuit B is brighter, they say. Which relationship is correct? You know what? Looking at the options, they're talking about thickness of wire and all. Very quick one. If you got a thicker wire, E increases, resistance decrease, current flow will increase. A thicker wire, very easy to flow, easy for current to flow, very low resistance. I let the current just flow smoothly. So that's why higher current and the bulb will become brighter. If you're wondering, is there a formula that deals with this? There is. The formula is R equals to this one, R equals to lambda times L divided by A. Yeah. So this is a very common question actually. You might be thinking, teacher, where got thickness? Thickness is the area lah. The cross-sectional area of the wire. How big the area is the thickness. Okay. So when your A is bigger, your R will be smaller. Your current will be higher. Okay. So let's look for greater thickness, smaller resistance. Thicker wire, lower current, no. Thicker wire, easier for current to flow. Thicker wire, lower resistance. That's correct. Because if the area big, then the resistance very small. Answers boy. If smaller thickness, then brighter bulb. Oh, that's false. In the picture, they already say if the thickness is less, this one is not so bright. And then smaller thickness, potential difference decrease. Also has nothing to do with the potential difference. It's between the resistance and the current. Yeah. Okay. Best answers, boy. Question 29. The diagram shows voltage of 240, resistance 25 ohm, and current of 9.6 ampere. How much power is dissipated by the kettle? Okay. This one, power normally we will use, because you have voltage, you have the current, you have the resistance. Okay. Power normally we will use the formula P equals to VI. And if that is what you did, you're going to get the answer already. Okay, all the other answers are pretty far off and they're wrong. Okay, so that means you don't need to use a lot of those in other information, but if you want to also can, you can say like, let's say power dissipated normally by a kettle. When I say power, by the way, power is the same as energy in 1 second. Energy divided by time. How much power means how much energy you release in 1 second. Yeah, so the energy is usually released in the kettle as in a form of heat. You lose the power, you lose the energy in a form of heat, which is why you can also say, if you want to find the formula, find the answer using P equals to, instead of VI, you write the V as, because guys, we know V is equals to IR, right? You can write the formula as I squared R. And I think you will get a similar answer. Current is 9.6, resistance is 25. Yeah. Okay. Another version that you can try also is P equals to V squared over R. And where this came from? This came from you replacing current, by the way, is the same as V divided by R. Okay, so you replace the current, you write current as V over R, then you're going to get V squared over R. and you try and see, I think the answer will also be similar. Yeah. Okay, question 30. Diagram shows graph of potential difference against current. What is the magnitude of internal resistance? Let's say you read the question, you are lost. Some students, they are very fast. They know, teacher, this one, go and find the gradient. The gradient is the answer. That's right. But let's say you don't know. But you're thinking like, okay, they want to find internal resistance. So I go to my formula sheet. I take a look at all the formulas here. Do you notice there's only one formula that can help you to find small letter r? Only one, number 7. Only this formula can help you to find internal resistance, number 7. Okay, and that is the one that you're going to use. Yeah, this is a graph for your e.m.f. and also your internal resistance. Okay, so got a few ways to do this. Like I said just now, some of you say, teacher, go and find gradient, you can get answer already. Another way is, some of you will also say, teacher, if I have a current of 3 ampere, and also I have a voltage of 5, yeah, and I also know 3 volts is the e.m.f, can I sub all these values in the e.m.f, the V, and the I, and I try to find the R? Yes, you can. But you must first know that 3 volts is your e.m.f, or else you cannot solve. When do we get a e.m.f? We can only get the e.m.f value whenever there is 0 current flowing. When there is 0 ampere, the voltage, the voltmeter value will give you e.m.f. So this one depends on your understanding on e.m.f, you know. Yeah, so you need to know to get e.m.f, voltmeter reading must be, sorry, ammeter reading must be 0. There shouldn't be any current flowing. Then only you're gonna get e.m.f. Okay, so this is 3, this is 0.5, current is 3, resistance is R. 3 minus 0.5, you get 2.5. 2.5 divided by 3 is R. R will be equals to 0.833. Okay, but honestly speaking, those of the people who know e.m.f is equals to 3 would probably know, remember I told you got different methods, would also probably know that you can actually go and rearrange your formula. Maybe I terbalik this formula. I write V plus IR equals to E. And you can go and rearrange this into Y equals to mx plus C. Your y-axis is V. You move the IR over, you get negative IR. But instead of negative IR, I'm going to write it as negative R times I. Same, negative I times R and negative R times I, same thing. Reason why I do this is because V is my y-axis, I is my x-axis, negative R is my gradient. The e.m.f is memang the y-intercept, which is what we talked about earlier. Which is why I said a lot of students would know the gradient is negative R, or negative R is the gradient. Okay, so you want to find R, you need to find negative of the gradient, let's say. Yeah, so I move the negative sign, or maybe I do worry about the negative later, but how do we find gradient? You write down a few coordinates. This coordinate is 0, 3. This coordinate is 3, 0.5. You take y value, y2 minus y1 over x2 minus x1, let's say. You definitely get the same answer. Negative 0.833. Okay, why got negative? Because it can cancel later. Okay, so looking at the question, it should remind you what formula you can use. Okay, what formula you can use. But be careful, guys. Sometimes in paper 2, they will say using your graph, according to your graph, or using your graph, state how to find the internal resistance. To use your graph to find internal resistance, you have to use this method. You have to say the internal resistance is the gradient. You cannot do the substitution method. They're asking you, how do you find it using the graph? According to the graph, it is the gradient. Yeah. Question 31. Diagram shows an electric generator. What type of current flowing in resistor R, and what is the magnitude of induced current? Okay, a simple one. If you have a split ring, confirm it is an AC generator. If you have a commutator looks like this. The ring split into half one. Split ring commutator. Oh, by the way, there is a spelling error. It's not called split ring. This one is called slip ring. This kind is called split ring. But normally we just call it a commutator. So if you see the ring split into half like that, that one is called commutator. That one will always give you DC. If you see got two separate rings, we call it slip rings. That one always will give you AC. Okay, so according to the picture, answer can either only be C or D. But will this coil give us a maximum or a minimum induced current? That depends on how much cutting of magnetic flux does that give us. Okay, so guys, a lot of magnetic flux flow from north to south like this. Okay, but please focus on your wire, this orange color wire. Let's say my two hands are the wire. And imagine a little bit, in front of me, I have a lot of magnetic flux, magnetic lines. Now, according to Faraday's law, I need to be able to cut those lines, cut those magnetic flux to induce a e.m.f. and then induce a current. You cut the lines, you will get more current. Now imagine you have a lot of lines in front. The orange color coil are my hands. My hands are the orange color coil. Now, as the coil, because the coil keep on rotating, one generator will keep on spinning. So it keeps on rotating. As it rotates, it is going to cut a lot of flux because the lines are horizontal and you are cutting the flux. So in this position, it is cutting a lot of flux. The lines are horizontal and you keep on cutting through them, cutting a lot of flux. Meanwhile, when let's say the generator rotates to a position this way, guys, this way, the generator is not cutting a lot of flux. Why? Because the magnetic lines are horizontal, they are straight like this. But then your generator, your coil, they are rotating this way. The lines are like that, horizontal, and then you are cutting like that, which means you're not cutting a lot of flux. This is not good. But like this, you're cutting a lot of flux because the lines are horizontal. So this way, you are cutting maximum flux actually. Answer is C. Yeah. Okay, question 32. The diagram shows a catapult field produced when a current carrying conductor is in a magnetic field. A catapult field can be increased by by the way, not the catapult. By the way, there's no such thing as catapult force. Normally, okay, not no such thing as catapult force. We rarely call it catapult force. Maybe, okay, I shouldn't say there's no such thing. We rarely call it catapult force. In your textbook, we normally call it catapult field. The catapult field produces a force. Okay, but basically it's this force that they are talking about. How to get more of this force? Increase distance between magnet. Confirm wrong. Magnet further apart, then the magnetic field will be weaker. Use a curved magnet. Normally that will help. But let's look at the other choice. Use smaller diameter of conductor. If you use a very thin conductor, a very thin wire resistance will go up. Then there will be less current. Then the magnetic field around because by the way, your current carrying conductor, this piece of wire that has current, whenever current flow through a conductor, there's always going to be very strong magnetic field around it. Okay, there's going to be some magnetic field around it. Now, if you have very little current flow, then the magnetic field will be weak. Then the force also will be weak. Okay, you know what I mean? So you don't want resistance to be high. You don't want the current to be low. Because less current flowing, less or weaker magnetic field. Okay, increased length of conductor, that doesn't really do anything. other than the fact that increasing the length normally increases the resistance a bit, then again, current will drop. Best answers, boy. Use a curved magnet. Because why? If a magnet is curved, okay, sorry, very ugly this picture. If a magnet is curved, usually it can help you to focus the magnetic field to the center. We say it gives you a radial magnetic field. It focuses more to the center, and also, if you do like this, it will be closer to the coil. Okay, it gives you a more uniform distance when around the coil. Yeah, so curved magnet can help to focus it to the center and give you a better interaction between the two magnetic fields. You're gonna get a stronger force as a result. Okay. Question 33. Diagram 26 shows two transformers, X and Y, which has different output voltage. The number of turns of coil is the same though. Which pair of factors is correct? They ask you, what are the factors causing the voltage to be different? Even though I coil the same number of turns, but why one less voltage? Why one higher output voltage? I assume that is because one of the transformer is not so efficient. One of the transformer is more efficient. There's less energy lost. Okay, so let's see. One used copper, by the way, X is less efficient, more energy loss. Y is more efficient, higher efficiency, or I just write more efficient. More efficient meaning got less energy loss. That's why even though I coil the same number of turns, I get more voltage. Okay, nichrome has low resistance. I'm so sorry, high resistance. So current flow is very little. It will make it worse. Yeah, but right, why is supposed to make it better? Copper wire is the better one. If you use laminated iron core, I feel it should be here. Solid iron core, these two should be terbalik also. Okay, because laminated iron core can reduce the eddy current. If you use steel iron core, soft iron core, I think this one's correct. I think why use the correct iron core, soft iron core, while transformer X is maybe using a not so good iron core, is just using a normal steel iron core, which is why one is less efficient, one is more efficient. I think that is a good reason why. One use a diameter that is bigger, one use diameter that is smaller. I think these two also terbalik, because the diameter of the coil wire, the thickness, when it's smaller, it is less effective. Yeah, supposed to be terbalik. Okay, soft iron core, very good at magnetizing and demagnetizing. Okay, can magnetize, demagnetize very fast. Soft iron core makes it more effective. If you all have heard of the term hysteresis before, it reduces hysteresis. Normally, essay, we just say, I use soft iron core because it can easily magnetize and demagnetize. Yeah. Okay. Question 34. Which statement is correct when the switch is on? When you turn on the switch, current will flow like this. The diode will allow it to flow, so the bulb will light up. Okay, when current flow like this, the diode don't allow it to flow, right? You must be same direction as this arrow, the arrow of the diode, then only allow it to flow. So this one cannot flow, bulb does not light up. Okay, which statement is true? Bulb A and B light up because A and B light up already wrong. Bulb A and B don't light up, also wrong. Bulb A light up because diode is in forward bias, but B don't light up because it is in reverse bias. Correct. Okay, if you don't know what is the meaning of the word forward bias, reverse bias, make sure you know this term. Forward bias means you connect correctly. Connect the right way. That's why current can flow from positive, flow. Okay, reverse bias means you connect the wrong way. battery current want to flow like that, but then you connect the diode the opposite way, so cannot flow. Okay, donkey, A don't light up. That one wrong already. A light up, B don't light up. Okay, answer C. This is on your semiconductor diode. Question 35. The diagram shows a rectification circuit. Which of the following is a correct direction of current flow? Normally, here we put a AC, alternating current, where the current will flow from the top, from the bottom. Keep on alternate from the top, from the bottom, from the top, from the bottom. But right now, it is a DC. Don't worry, it will still work. Current will flow like this. Okay, and then when you are at a crossroad, always remember, one of the guys, they will block the flow. Like, can you flow here or not? Cannot, because the diode is this way. So obviously, here will block the flow, but here will allow the flow. So that would mean current will flow from M to N. Now, can it flow this way? It can't. Again, why? Because the diode is blocking it this way. So it will block the flow, which means it is forced to go through the resistor. When we say a resistor, it means, by the way, you can put anything here. You can put a bulb here. A bulb is a resistor. You can put your handphone here. Your handphone also got resistance. Maybe you want to charge your handphone. Okay, it will also go to the CRO lah. Like that is the monitor screen to show you the pattern of your current and voltage. Okay, but then you're just gonna come back, go to here. Now here's the thing. Some people say, teacher, this one current can flow. Teacher, this one current can flow. So you might think can be both. But remember, if the diode already blocked the flow earlier, just now already blocked the flow, it cannot allow the flow again one. Just now already blocked means it will block already. So where will it allow the flow? It will allow the flow here. And it will flow through this way. Must remember, the current must always go one whole round and must come back. Don't go one whole round and then go missing and then don't know go where. You must go one whole round and always come back. And you will notice for all the 4 diodes rectification circuit, this is normally a full wave rectification circuit. Current will only flow through the opposite diodes. Either they flow through these 2 or they flow through these 2, the opposite ones. Okay, right now current flow from M to N, then to T and S. M, N, T, S. Okay, M, N, T, S. Answer C. Answer C. Okay, question 36. This is a structure of a cathode ray oscilloscope. Guys, we just want to create a cathode ray. Okay, for you to create a cathode ray, you must make sure that because you have a lot of electrons here, you have some heat supply, and then the cathode is going to have a lot of free electrons. The heat supply is going to give energy to the electrons. The electrons will come out of the heated metal surface. That is called thermionic emission. Okay, chapter 5.1, thermionic emission, where electrons are emitted from a heated metal surface. Now, if you want your electrons to move, to accelerate, you must make sure that it must go from negative to positive. Then only you can push it forward. Right? So this question is just asking, do you know that electrons are negative? Do you know cathode ray means electrons, a beam of electrons? To move the electrons, it must always go negative to positive, because if you terbalik, the electrons won't move. Electrons will be attracted to the positive side. So P must be negative, Q must be positive. Answer is boy. Okay, that's question 36. Question 37. A strong radioactive substance in a solid state needs to be transferred from an experimental site to a store container. Which is the best safety precaution to handle this situation? A radioactive substance means something that emits a lot of radiation. Radiation comes in a form of, in your syllabus, comes in a form of alpha particles, beta particles, gamma ray. They keep shooting out all these particles, which can be quite harmful for the human body. The best way is to use robotic arms. Don't ask humans to do this job because it's very dangerous. Use robots to do it. Okay, use robots to do it, to move from an experimental site to a store container. If you use forcep is like the kiap. Yeah, you still need human to go and take, you know. If you just wear a radioactive badge, you wear a badge. The job of a badge, right? Normally lah, is for those hospital workers where they work a lot in those X-ray rooms. Those rooms where you need to go and do X-ray scan. Those workers, it could be a doctor, it could be an actual doctor, it could be a normal non-doctor, but normally they'll wear a badge. Now, this badge represents how much X-ray radiation you are exposed to. So after 1 month, I will see this badge. If I look at your badge and I see that you are exposed to too much radiation, then maybe you cannot work in this X-ray room for too long because your body is exposed to too much radiation. So maybe they will ask someone else to go and change. So the badge tells you how much you are exposed to, or you keep a substance inside a metal container. No, I want to transfer it, right? So the best way is to use robot to do it. A robotic arm. Okay, question 38. The diagram shows a nuclear reactor to generate electrical energy. Which of the following is a correct match? Okay, graphite moderator and control rod. I always say, for moderator, yes, you must choose graphite. The purpose of moderator, I tell my students to remember this. It sounds weird, yes, I know, but graphite moderator is to slow down the neutrons. Okay. Another one for control rod. Control rod, I'll remember like this. Control rod, we buy CD to control airports. I know it sounds weird, really, it does. But I've tested many times with my many batch of students and they always remember this somehow. Yeah, and it works. As long as it works out. So you want to find other ways to remember, go ahead. By all means, go ahead. But earlier on, graphite moderator, the job is to slow down neutrons. Boron, B stands for boron. CD stands for cadmium. Control rod. Okay, so got SPM essay question also got asked, control rod, what should you use? You should use boron control rod, or you should use cadmium control rod. What is the job? What is the purpose? The purpose is to absorb. One is to slow down. One is to absorb. And students always confuse which one is which. Is it the moderator or is it the control rod to slow down to absorb? This one to absorb excess neutrons, all the extra neutrons, to slow down the chain reaction. So let's see. Moderator to lower temperature. No. Lower temperature is the job of the water, the job of the cooling agent. Normally water. Okay. Boron control rod to make the speed slower. No, that is the job of the moderator. Graphite moderator avoid leakage of radioactive ray. No, that is the walls. I want a thick concrete wall normally to do this job, to block the radiation. Lastly, boron control rod to absorb excess neutrons. Answers donkey. Okay, that's 39. 38, sorry. Okay, then we look at question 39. Which of the following is the advantage of using nuclear fuel compared to fossil fuel? I want to look for advantage. Okay, advantage, reduce global warming. No, it doesn't reduce global warming. You know why? Nuclear energy will produce a lot of heat also. Right? Let's say you got a bomb. The atomic bomb is like a nuclear reactor. It will produce a lot of heat. Yeah, so it doesn't reduce global warming actually. And same thing, you go and burn fossil fuel, like you go and burn those your fossil fuel is like your petrol or uh, your crude oil and all those things, fossil fuel, your petrol, diesel, bitumen and all those things to generate electricity. When you burn also got global warming, so not the best answer. Nuclear fuel is renewable. No, because uranium is not renewable. Yeah, on Earth right now, we mainly use uranium to power all our nuclear power plants. And we use uranium. We use nuclear fission. Uranium is non-renewable. That means one day we will not have enough uranium. Okay, there'll be less environmental impact. That sounds like an advantage to me. Why? Because nuclear fuel can generate a lot of energy by using a small amount of reactant. A small amount of uranium can give me a lot of energy. Meanwhile, fossil fuel, you need to burn a lot of them, then only it can give you the same amount of energy. So there'll be less environmental impact because you don't burn so much. You don't have to keep on burning a lot. You don't have to burn so much. Okay. Uh, Uranium is, yes, quite costly usually. Because quite hard to find uranium. Quite costly. But I don't think high cost is an advantage though. So I don't think this is a good answer. This is a disadvantage. Yeah, the best one out of all, you choose the best one. Answer is C. Okay. Question 40. Which of the following involves in nuclear fission? Fusion, sorry. Fusion is combining very light nuclei together and it forms a nucleus, a bigger nucleus. Okay, and of course, it will give you quite a lot of energy. Usually, nuclear fusion, it happens in the sun, inside the sun. That's why the whole sun it's like a fireball like that, because there's so much of nuclear fusion that keeps on happening on the surface of the sun, right? And the surface of the sun is filled with hydrogen. Hydrogen is the lightest atom that we know, the first guy in your periodic table. A very light hydrogen fused together to form helium and give you some kind of energy. Yeah, that is nuclear fusion usually. That is the end of your 2021 paper 1. Yeah, some of the questions were pretty trickier, but a good paper to go through. Okay, we stop here.